Hi, good morning, and welcome to the ZP Developer Zone. So we like to do this Developer Zone every Thursday at 8 a.m. London time, a little bit early. Again, off to conferences, so we do have to go a little bit earlier today. But let me jump into it and just say we do have the ZP Academy. There are free courses on there. We do have the webinars. We do webinars weekly, and we also have big webinars monthly. And we do have collaborations. These are definitely taking place with Norway and the UK. We do have jobs, we do have a developer zone, and we do have workshops. Workshops probably one of the most significant educational things that we actually do, and training things that we do. If you see a link pop up, I'll make sure I put the link underneath the video as well, so that you can find it. But we do have workshops running in December, and we have in November as well. So this month and obviously next month. And again, I'll put the link underneath. Let me go a little bit quicker and just say we do large live streaming webinars. We do one on our Julie Cloud. This is a cloud management system. There is a freemium sign up for that. We do them on Sense It All. Sense It All is relevant to today's conversation because you'll see that our Sense It All platform is actually really similar or the same as our R&D platform, but I'll get into that in a little bit deeper. And we do have our Food Sense live streaming webinars. These could be interesting for anyone who's interested in literally measuring the chilliness of ginger. Well, it's not the chilliness of ginger, the Scoville heat unit of chilies, the pungency of ginger, the total antioxidative status of food, and we're talking about adding alcohol to it as well. So that might be an interesting webinar for people as well. We will have our S-Cubed conference in the UK on the commercialization of electrochemical assays, and we will have our early bird registration for that. Again, here's that link to some much larger webinars that we're doing as well. We also do corporate workshops. These are much more for companies who want us to come on site and do live demos and live events at there. Now, question number 5 popped up first, but let me go into question number 1A. Is it possible to make your SPEs for arsenic detection? I will answer that question today. On the life expectancy of your SPE options, that's an interesting question actually, because all of our SPEs, well, I'll make a recommendation, which is going to be the hypervalue carbon electrode, which the people have found out for themselves. We have used it in this application. The lifetime expectancy is always the hardest question. I do have videos on technology readiness level, manufacturing readiness level, and application readiness level. And so whenever people ask me about their application, I always just say to them, look, our technology readiness level, especially on the SPs, is really high. You know, we've been doing this for 9 years now. Our manufacturing readiness level is very high. You know, we can make these in the millions. The application is the unknown. That is the science that you're about to go embark upon. So is it, are they robust? Yeah, they're robust. But see, when you do wet science, you bring the liquids to materials. You have very little control as a manufacturer of how people are actually going to do that. So they really do have to get into the science of actually doing it in order to answer that question. How many times can an electrode be used before the electrode had to be polished? Again, that really is an application question. And just to say that when you have this mindset of polishing, it's because you're thinking about these kind of disc electrodes where people do polish them. We do have videos about polishing electrodes. If you Google that, you may find them, but it's not something that I super recommend, especially on the carbon electrodes. They're too, polishing is abrasive. Carbon is a sort of a layered material. And if you think about graphite, and you'll end up just sort of polishing it away. Do not go for the chloride resilient reference electrode at the moment. You're in your first experiment. Just go for the simplest electrode, which would be the hypervalue electrode without the chloride resilient electrode. Then build up complexity. Don't jump into complexity. I think, that would be my kind of recommendation on that. Just out of interest, the technique that you're looking to do is called anodic stripping voltammetry. So your question is, can we detect arsenic? Here there's an anodic stripping voltammetry where I've got a waveform for what anodic stripping voltammetry is in a bit, but this is zinc, cadmium, lead, arsenic, and copper. So you can sort of be specific towards arsenic because it's in the it's the sample type, and also the specificity comes from the position of this peak in the, let's say, in the raw signal. So I have seen people do synthetic biology and then make an arsenic sensor doing that. These things never go well. They end up doing a lot of science and it never works. And if you're looking for a nice simple way of measuring arsenic, then the keyword for you is anodic stripping voltammetry. So the position tells you what it is. So that's copper, and then AS next to it is, for example, arsenic. And the peak height tells us that it's copper. Oh, sorry, tells us how much copper actually is in there. But you have to do those calibration curves yourself. We're quite lucky because we actually send the data to Julie, which makes me think, yes, you should come to the Julie webinar. And I'll put a link in the description, but just come to it anyway. Here's the hypervalue carbon electrode. Again, I recommend you don't go for the chloride resilient one. It's too early days at the moment. Just stay, you're going to be working in synthetic buffers to start with anyway. So just start there. It's lower cost, and you can you basically make mistakes at a lower cost. That's always a good idea. Just out of interest, we have done this kind of heavy metals detection, not so much arsenic, but lead and copper. But so we have done this kind of work, and we have done it on the hypervalue carbon electrodes. This is an ASV, anodic stripping voltammogram, done by us. The technique is not that hard. You take your hypervalue carbon electrodes, you apply a negative potential, that plates out the copper, and then you use a stripping potential that then reoxidizes the copper, and the amount of copper that comes off is proportional to how much was in the original sample. It's quite a robust technique, quite easy to implement, and can have good linearity and, as I say, speciation: copper, cadmium, lead, copper. Sorry, zinc, cadmium, lead, copper. This is the waveform itself. Now the waveform, I can advise you once you have actually one of our hardware instruments, but otherwise you can find this kind of waveform in the literature. This is kind of it's interesting what you just said actually. Or the question was, do we need to clean it? And the answer is they generally use a kind of positive potential to clean the electrode, then these kind of negative potentials to coat the electrode, and then they scan the potential in a positive direction again to reoxidize those metals, and that's when you get the kind of peaks as each metal. And the metals come off in a particular order. Zinc being the most reactive comes off at the most negative potentials, and then copper would be the most sort of inert, comes off kind of last, and then arsenic is sort of after zinc but before copper. Anyway, that's the waveform, and there we are. That's the kind of I've sort of sketched it in what you should sort of get when you're doing this kind of work. We've also done it with lead as well, not super hard, so we have done it with our hardwares on lead, and I think here we actually have. Look, I can see here that we would sort of, with lead, we were down to kind of 5 ppb, or limit detection was around about 5 ppb, but we haven't overworked on this kind of work. What we've initially done. We do have the Kate potentiostat. If you do get the Kate potentiostat, it's a good potentiostat for doing this kind of work, and I can recommend it, and I can say it will work. So I will put a link to Kate, and I may not have put the link to Kate. I haven't, but I will add a link underneath in the description box after I have finished. Just to say, if you want smaller batches from the USA, I'll also put a link to this company as well, IO Rodeo. They do have a couple of they do smaller pack sizes in the US, so that might be an economic way of and there's the link. And as I said, I'll put the links underneath there. So the question number 1, is it possible to make an SPE for arsenic? Yes, you can use the hypervalue electrodes, and you can use the anodic stripping voltammetry. The life expectancy of your SPE, yeah, they have a good life expectancy, but the application, it's all about the application. So you do have to get them and get into the lab and do that work. In fact, when I think about anodic stripping voltammetry, it has a built-in cleaning step. So you have to optimize that cleaning step in that assay. I don't think you need a chloride reference electrode, not in the initial days. You need to get on with doing some checking out that working electrode and then worry about the reference electrode. There are options in the USA for less than 200. IO Rodeo have them. So I think that's a thank you very much. If you have any questions, don't hesitate to reach out to us. I'll try and make sure I put all the links. If I was missing a few links in the presentation, make sure I put the links in the description underneath. Okay, thanks very much.